Hello friends, welcome back to the channel for another Databricks video. Today's video is about Delta Live tables. I'm new to Delta Live tables myself, which is a good thing as I can get a better understanding of the product and evaluate it without any bias. According to the documentation, Delta Live tables is one of the best ways to do an ETL process in a lakehouse. It's responsible for creating, maintaining, and testing the data flow pipelines using a declarative approach, which helps data engineers to focus on getting the value out of the data rather than focusing on the tool, which is what we like as data engineers, unless you like configuring things. Personally, I do prefer playing with data and building data pipelines. Let's talk about the key benefits of working with Delta Live tables. First, it accelerates the ETL process. We can use SQL and Python in conjunction with Delta Live tables, so we can automatically orchestrate DAGs, we can handle retries or transform data. Second, we can automatically manage the infrastructure. Complex, tedious activities like recovery, auto-scaling, and performance optimization against the workflow. Third, and I think that's the most important thing, we can ensure high data quality. We can deliver reliable data with built-in quality controls, which I think is amazing and one of the most important features of Delta Live tables. Guys, remember in our previous video we built a Delta Lake based on the Medallion architecture, which is the recommended architecture by Microsoft. We are going to use the same logic in this demo too. We are going to use EventHub to capture streaming data sent from our Python script and save it into a storage account in Avro format. Then we are going to use autoloader in Databricks, and we are going to pick up the data automatically from the storage account as they come and start creating a Delta Lake using Delta Live tables. We are going to use both Python and SQL to do this. Now let's jump into action. This is Databricks documentation where we can see an example of how to build a Delta Live table step by step. As you can see, they use the Medallion architecture as well. For us now, what we want is to create the bronze layer. So how are we going to do that? We are going to use EventHub and send data from our Python code to and capture this data into Avro format in our data lake. Remember, I'm going to use the same Python script that we used last time to stream data into EventHub. So let's go to our Azure account and let's create a new EventHub namespace. So click on Create EventHub's namespace. Select your resource group. Select a namespace name. So that would be, let's call it EventHub Delta. Select your location, West Europe for me. And then select the pricing tier. Now be careful here, do not select the basic one because it does not provide this capture capability which we want, and we have to use the standard one, which is a bit more expensive, but it's worth it, believe me. Throughput units is one, that's fine. Click on next, next, next. Review and create, and let's create an EventHub namespace, which is the first step. Give it a second, it will take a minute or two. EventHub namespace has been deployed, so click on the Go to Resource. And what we have to do here is create an EventHub instance. So scroll down to the EventHubs under Entity, click on Add EventHub, select the name. So let's select name. Partition count is 1, fine. Next. Here we have to use the capture capability, so turn that on. Now minimize that, we don't need anything fancy here. Point to the storage account and let's select a container. And that would be, I have plenty of storage accounts. As you can see, click on a container and this is how it will capture the data in Avro format, right? Authentication is SAS, that's fine. Review and create, and now that we have our EventHub instance, we can start streaming data into our data lake. So what we have to do here is actually select your EventHub instance, go to Shared Access Policies, click on Add, let's create a new policy, select Manage, click on Create, and now with that new policy, we can get the connection string primary key. So copy the connection string primary key, and this we are going to paste this into our Python script. Let me switch screens and let's paste it here into the connection string. Now the event hub name, what was that? It was event hub. So select your event hub name, paste it here, and we are ready to run the script. It's exactly the same script that we used in the previous example. We generate random data. Let's say we have a device ID that produces RPM, angle, humidity, wind speed, temperature, device timestamp, and device date. So everything is an integer except for the dates. As you can see, we started streaming data. Now, if we switch back to Azure, we should be able to see the data captured in our data lake. Let's move to our data lake and see what we got. Our storage account, our containers, test, and here, as you can see, we have EventHub Delta and EventHub. And here you can see we start receiving data, new data, right? This is in Avro format. And as you can see, we have to follow the whole path to get the data. It's partitioned by date. That's why you have so many folders. Okay, now the point is to get the data from here automatically to our Delta Lake in Databricks. And we are going to do that using an autoloader. So let me switch to Databricks. Let's take a look at the Python script. So the first thing we need to do is import the Delta Live Tables library. Here, as you can see at the top, the first library we import, and then we need to use all the PySpark library to import functions and types, struct type, etc., etc. Moving on, we have to set the account key in order to access our data lake and stream the data from the data lake. We provide the JSON schema here, and we have device ID, RPM, angle, humidity, wind speed, temperature, device timestamp, and device date. And now the cool part is here where we create our first Delta Live table. As you can see here, we use annotation. This is in fact a decorator, a Python decorator. So a Python decorator is where we pass a function into another function. Just take a look at decorations in Python and you will get a better understanding. And here we actually create a Delta Live table. You just use you add comments here if you want, passing this bronze function, which returns the data that we are streaming from our data lake using an autoloader. Now, as you can see here, we say spark.readstream.format cloud files, and option, we have to specify the format of the cloud files, which is Avro. And then we point to the data lake, right? So this is the full path to our container. Remember, that's the test container. And then these are the directories where we have saved the data. You can find this whole path here in your data lake. You can see EventHub / Apple EventHub / 0 / 23 / etc., the whole date, right? And then here, as you can see, I used * to select all the data in all those directories. And then we cast the body as a string, we pass the JSON schema that we provided up here, and we select the columns from the incoming stream. Now, this part here is not new. We discussed this in the previous video. The new thing here is the cloud files, and the autoloader. If you don't know what an autoloader is, let's take a quick look at the documentation and see what it says. So autoloader incrementally and efficiently processes new data files as they arrive in cloud storage without any additional setup. Autoloader provides a structured streaming source called cloud files. Given an input directory path on the cloud file storage, the cloud files source automatically processes new files as they arrive, with the option of also processing existing files in the directory. Autoloader has support for both Python and SQL in Delta Live tables. What do we gain from using autoloader in Delta Live tables? There is auto-scaling, compute infrastructures for cost savings, data quality checks with expectations, automatic schema evolution handling, monitoring via metrics in the event log. We do not need to provide the schema or checkpoint location because Delta Live tables automatically manages those settings in our pipelines, which is so cool if you think about it, right? So we are going to create a new table called bronze here, because automatically the Delta Live table will be created, named according to the function that we pass in our Delta decorator, right? In our Delta Live table decorator. And here we pass the bronze function. So the name, the Delta Live table name, will be called bronze. Now moving on to the silver layer here. Let's scroll down and see the next cell here. Here we have defined a new Delta Live table. It will be called silver, which is how we call the function, right? And here is the Delta Live table decorator that we pass our silver function here. As you can see, there are two checks, two constraints, which is DLT, which is the decorator, and then dot expect or drop, and that's the constraint name, device angle. You can call it whatever you like. And here is the constraint, device angle is not null. Or another constraint, so here, if this device angle is not null, so if it's null, it's going to drop this this line here, this record. It's going to drop this record. Here there is another constraint, which is expect or fail. So if the temperature, here is the constraint name, but here is the constraint itself. So if the temperature is greater than 0, then that's fine. If it's not, it's going to fail. So the whole step is going to fail, not only the record as we did here. And our function that returns, we are reading from the bronze layer. As you can see, we are using DLT here, dot read stream, the bronze layer, which is the table that we created here, right? On the first step. So we read from the table, and then we can perform another, say we can cast device ID as int. It's already in an integer, but let's say this for, that's the sake, we do that just for the demo. And here we can rename the column, so angle to device angle and RPM to device RPM, and we can select the columns that we want, right? Now let's see what the documentation says about the expectation. So let's go. And here is how you manage data quality with Delta Live tables. You use expectations to define data quality constraints on the contents of a dataset. Expectations allow you to guarantee data arriving in tables meets data quality requirements and provide insights into data quality for each pipeline update. You apply expectation to queries using Python decorators or SQL constraint clauses. Perfect, and I think that's a very, very important feature because you can apply all those constraints. It's so easy to apply all those constraints, and be certain of your data quality and the data that it arrives on the next step, which I think this is the most important feature, at least for me, for when it comes to Delta Live tables. Last but not least, we have the gold layer, and here again we are going to create a Delta Live table using the Python decorator. It's going to be called gold. That will be the name of the Delta Live table, and it's going to return pretty much the same thing. We just rename another column and then we select the columns we want. We perform filtering just for the sake of it. And using delta.readStream and the silver table that we defined in the previous step up here, it's going to create the gold layer. Perfect. Now let's create our first Delta Live table pipeline. So here on the blade of Delta Live tables, click that and click on create pipeline. Select the pipeline name, Python demo. Product edition, just use the advanced one for the time being. The pipeline mode would be triggered. We don't want it to be continuous right now. There's no point. And here we have to define the notebook we are going to use. So let me select the notebook that you created the code, and then select. We are going to use Hive Metastore for the time being because Unity Catalog is still in the preview mode. So we are going for with the certainties here with the Hive Metastore. So the target schema could be Python demo. Let's call it Python demo, right? And the cluster policy would be none. Cluster mode enhanced auto scaling. Now we can use a fixed size here and could be 0 because we are only going to use the driver worker. And you can add notifications if you want. Just select a user mail to send email if the pipeline fails, or if it succeeded, the channel use current. Click on create. And this is going to create our new Delta Live table pipeline. Let's start and see if we get any errors. So everything works fine. Everything seems to be working fine. Let's see. So here right now we are streaming the data from our data lake to the bronze layer. Now right here to the silver layer and finally to the gold layer. As you can see, everything is green. That's good. Usually if it's red, it's not going to work, but now it's green, so everything looks fine. How can we see the data? Well, go to the data, and under this Python demo schema, you will see the bronze layer. You can select the sample data to see a few data, right? It's going to take a while. Now, bear in mind that you can see the sample data here, the same for the gold layer and the same for the silver layer. One thing, as you can see, we have less data to the gold layer on the gold layer because we filtered out data, right? So everything is working as expected. Now, bear in mind that Delta Live tables, they spin up a cluster when we create a pipeline, right? A Delta Live table pipeline. But also we need to create another cluster to interact with our notebooks. And that's why, as you can see here, if we go into compute, you will see I have spinned up a cluster. I have created a cluster just to interact with the notebooks and run, queries. So I have another notebook here that we can use in order to check the data. So let's use the Python demo database that we created, the schema that we created, and then select from the bronze layer, and we should be able, to see the data that we got from the data lake. The same for the silver layer. We can query the data and see the data here, and from the gold layer as well. Perfect. Another thing I have to mention here is that we cannot use Delta Live tables. We cannot combine, when we use Delta Live tables, we cannot combine Python and SQL on the same notebook. So it's not possible, it doesn't allow it, at least at this point. So in order to use the SQL version, we have to create a separate notebook. And so let's see the SQL version. That was pretty much similar, but a bit different because we had to use SQL and the syntax is a bit different. So the first thing we have to do here is to create or refresh a streaming table. Let's call it SQL underscore first underscore step as select from cloud files. Here we are using autoloader. As you can see, we are using cloud files and we are using autoloader. The difference here is we cannot use the account key like we did with PySpark. It's not going to work. So what I did was to create a mount point pointing to the data lake. Let's go back to our notebook where we create the mount point. And here, as you can see, we are using PySpark to set up the mount point. You can find that on the documentation. It's not something that, it's not a code that I came up with. Here, using Azure Service Principal, you can set your credentials, and that's the code I used, using a service principal to access the data lake. So when we use service principal here, we point to the data lake and we create a mount point called mount/EventHub delta, and then we can read the data. So if I run this command here, we can read the data using PySpark, but we can also read the data now using SQL and cloud files. So let's copy that and go back to our script. And here, let's paste this script here, pointing to our data lake, and get this the data that we have in our format. The next step is to actually create a bronze layer. Again, so create or refresh streaming table SQL bronze as we select and rename whatever fields we want, like we did here. You provide an alias, like in typical SQL, but we have an inner query that's a bit tricky. We have to select from JSON all those from the body. You have to select all those columns here that we have to provide the data types, like integer, exactly like as body. And then we have a second inner query that we cast the body as string. And it's exactly the same that we used if we go into the PySpark example. Here, as you can see, we used with column body, and we used from JSON, right? From JSON, we cast the body as string, and we provided the JSON schema, and then we selected the columns. We are doing exactly the same using SQL this time. So the first inner query streams data from, as you can say here, select cast body as string as body from stream live.sql first step, which is the first, you can see the previous step, right? That's the table we created in the previous step. So we stream the data from the previous table, we cast the body as string, we get the columns we want using from JSON, and select whatever we want and provide aliases. And this is how we create the bronze layer. Then we have the silver layer, that we use expectations again, the constraints that we mentioned before. This is that's how you define the expectations in the SQL version. So constraint, device angle, expect that the device angle is not null, and on violation, drop the record. So drop the record on violation of this expectation here. And if the same for the second expectation, if the temperature is less than 0, on violation fail update. So it's going to fail and not just drop the record like in the first one. And then again, we select from stream live.sql first step. We select all the columns that we want, and we can cast the device ID as integer again. And the last step is, again, to use just filter data where the device ID is greater equals to 10. Nothing much, but this is how we can create the gold layer using SQL. Again, the same syntax from stream live.sql silver, which is the table that we created in the previous step. So let's create a new Delta Live table pipeline using the SQL version. Let's create a new pipeline, SQL demo, called Product Edition Advanced Pipeline Mode Triggered. Select the notebook with the SQL version. And here we are. Apologies, my internet's a bit slow today. Select the notebook with the SQL, Hive Metastore. Let's call that SQL demo. That would be the target schema. And let's use fixed size, 0. Again, click on create. I'm going to start the Delta Live table pipeline. Probably we are going to get an error when it comes to resources this time. Yes, as you can see, we got an error. Failed to launch pipeline, cluster, etc. With termination code Azure code exceeded exception and termination type client error. Encountered code exhaustion issue in your account. So we exceeded the approved total regional cores. Well, you are going to get the same error when you first create your first Delta Live table pipeline. And what you have to do is actually open a ticket to Microsoft. It's pretty easy. You don't have to worry. I thought it would be a long process, but no, it provides you, the first time you get this error, it provides you a link. You click the link, you request more regional cores, and within a minute they provide you more cores, and you will solve this issue. Now, I'm not going to create a new request to Microsoft to increase my cores here because that's kind of expensive. So let's go back into our Delta Live tables and let's delete the previous Delta Live table pipeline. I'm going to delete the previous one, and once the previous one is deleted, we are going to run the SQL version, right? Click on refresh, and here let's start now the SQL version pipeline again. Nope, we received another error. Let's see what that is. Device ID couldn't be resolved. Did you mean one of the following? Castles. Let's see, something went wrong. Let's see our notebook again. And here, when we create the SQL Server layer, as you can see, we stream from the wrong table. We should use the SQL_bronze table because that was the right table to stream in order to create the silver layer. Let's go back and run our pipeline again. Third time is the charm. Let's see. It seems to be working fine now. As you can see, the first step is running, the second step is running. It is green so far. Then we have the SQL silver layer and the gold layer. And see what we get on our data. So if we click data here, you will be able to see the SQL demo, and all the layers here, and you can see the sample data. We can use also queries to check the data, right? Let's use SQL demo, right? Let's see. And then select from the gold layer. As you can see, we streamed 3 records. What we can do now is actually, let me run the Python script again, one more time, and send more data to EventHub and to our storage account. So I run the script is running, and then as the data is coming, we can run our pipeline again, right? So let's run our pipeline and stream the new data, the incoming data. It's running. Let's see what we should be able to see more data on the gold layer. This is running again. As you can see, they are streaming tables and the gold layer has been completed. So let's go back again to our queries and query the gold layer. As you can see, we received the new data. We have more records right now. And again, if we run the PySpark Delta Live Table pipeline, it would be the same thing. This is how you run a Delta Live Table pipeline using SQL or PySpark. Now there are a few caveats when it comes to Delta Live Tables. First of all, you require a premium Databricks workspace, so it's more expensive than the usual one. Right now I'm using the free trial, but as you can see, we have to upgrade to premium if we want to use Delta Live Tables. Another thing is, as we mentioned before, we can only use Python, but we cannot mix it with SQL. So each notebook has to be either Python completely or SQL. Another thing is you cannot use magic commands. Now I don't know if that's an issue for most of you. For me, not that much, but just to mention, you cannot use magic commands. So when you create an SQL notebook, you have to go to your notebook here, click on File, and change the default shell language into SQL. And last but not least, you cannot run the Delta Live Tables interactively. So if you try to run this cell, you're going to get this error here, which says SQL first step is defined as Delta Live Tables. To populate your table, you must either run an existing pipeline using the Delta Live Tables menu or create a new pipeline. So you cannot just run this cell like in normal notebooks. Bear in mind, I'm new to Delta Live Tables myself, so I might didn't explain everything very well or I made a mistake somewhere. Now, what is my evaluation regarding Delta Live Tables? I like them, especially the data quality checks. I like the declarative approach too. And this is what Databricks say about declarative ETL, what that means. So declarative ETL involves the user describing the desired results of the pipeline without explicitly listing the order steps that must be performed to arrive at the result. Declarative means focusing on the what is our desired goal, and leveraging an intelligent engine like Delta Live Tables to figure out how the compute framework should carry out these processes. I like that feature. As a data engineer, I would like to use Delta Live Tables. I think they are very convenient if you like focusing on data pipelines rather than configurations. Of course, it's expensive and the cost should be taken into consideration. This is it, guys. I hope you enjoyed the video and you learned something new. I'm going to provide the links in the description. The code could be found on my GitHub account. Thank you for watching. Please click the like button, leave a comment and subscribe to the channel. Thank you.